let's get started. I would like to introduce Kaizen's own Eric Miller.
Thank you, William. And good morning, good afternoon, good evening, depending on where you're joining us. Today we're going to talk about whether you need a pH neutral cleaner. pH is something that we've talked a bit about here on Tech to Tech, and you go to our website, there's really a couple nice packages on pH, and I hope you'll go check those out. But today we're going to talk about pH neutral. pH neutral is kind of that 6 to 8 range, with 7 kind of being the gold standard. If you talk about fluxes, most fluxes are in the 2 to 4 range. Kind of your traditional alkaline cleaners fall in the 11 to 14. They don't usually get as high as 14, but they can. And more modern balanced cleaners really fall in that 9 to 10.5, maybe 8.5 to 10.5, but certainly in that lower alkaline range. We talk about a cleaning process. It's got to do a few things. First off, it's got to clean. Second, it's got to be compatible. It's got to be compatible with your parts. It's got to be compatible with your equipment and generally your process that you're trying to accomplish. You've got to be able to control your process. That includes controlling the cleaning material that you're using and making sure you have a robust process, as well as it's got to meet any environmental and governance regulations that you have. So you can't really compromise on any of these. We look at pH neutral and some myths around it, or potential myths. You know, talk about a pH neutral cleaner. Yeah, it may or may not clean as well, but again, we're kind of giving up some cleaning potentially for some improved compatibility. Because being pH neutral, of course, it's going to be compatible with your machine and your parts. Being pH neutral, of course, it's going to meet all your ESG requirements, environmental, user. And, you know, again, should save you cost, should be cost efficient and cost available. We look at alkaline cleaners. We know they clean. They've been used for a long time. However, there's some potential questions about compatibility, whether those are parts or the machine itself. Because it's not pH neutral, of course, there's going to be concerns about the EHS and ESG. And again, they've been around for a long time, and some of the long traditional alkaline cleaners pose some cost concerns. So if we look specifically at pH and fluxes, and what does that mean to cleaning? Well, again, fluxes are acidic. So if we take this chart here, and this is a titration with the vertical axis being pH, the horizontal axis being the addition of a mild acid to simulate flux being loaded into the bath or bath loading. If we look at a pH neutral and a traditional alkaline cleaner, you can see that as you add acid, you add flux, those pHs drop and shift quite rapidly. You can take a look at the pH neutral product. It doesn't take very long to get to pH 5, which is considered acid. So how do you remedy that in a balanced cleaner? Well, you really want to protect this pH from shifting. How do you do that? You buffer it, and you add buffering agents. The problem with buffering agents are they do not allow you to remain neutral. What I mean by that is buffering agents tend to be acidic and or acid. So you can't, there aren't very good buffering agents that kind of fit in the middle. But if we do buffer them, you end up with something in that 10 pH range. And as you can see here, by buffering the cleaning agent at pH 5, you're getting 10 times the loading into the bath. So what does that mean? It means that as you're loading flux in, or you're adding flux, your bath is going to become acidic unless it's buffered. But as it becomes acidic, you're going to see a decrease in cleaning, you're going to see a shortening of your bath life, and there's going to be some effect on your compatibility. Speaking of compatibility, we compared a neutral pH cleaner with a balanced cleaner. Same concentration, same temperature, same exposure. And as you can see, there's some differences in the metals, the part markings, the labels, the different coatings. This doesn't even take into account the adding of the flux into the bath and the potential for that pH shifting and worsening the compatibility concerns. What does this tell us? This tells us that the ingredients in the cleaner are far more important than the pH alone in the role that they play in compatibility. This also starts to bring into question what the effect on your equipment is going to be if it's having these kind of instantaneous effects on your parts. When we look at some of the health and safety things, one of the first things that comes up is disposal. Most disposal will accept pH 6 to 10 without any problem. That could be a city or state disposal or simply a local at facility disposal. So pH is not a big deal when it comes to disposal. It's really about what you're dissolving into the bath that's the real issue. So typically that's dissolved soils or dissolved metals. And we also want to keep worker exposure in mind. When we start talking about the transportation, pH can certainly drive whether something is hazardous or not for transportation, but typically that's on the very high or the very low, very acidic or very alkaline. It really comes down to the SDS and the constituents in the cleaning material that drive whether there are any regulations on transport. As you start to load the bath, again, you can overcome that pH shift by increasing concentration and increasing temperature. However, by doing both of those, you're also increasing your impact on waste and energy cost, as well as the potential for impact to your equipment. When it comes to controlling your process, there's some important things. If your pH is shifting, you have the potential to create foam. And so one of the ways to resolve that is to increase your concentration. However, your increased concentration is going to increase your cost. Problem with cost is it's not solely about the concentration. It has a lot to do with the drag out. Drag out is the material being taken from the wash section or wash process to the rinse process, and or the evacuation and exhaust of your wash tank. That's where your biggest drag out comes. So not only is it an increase in filling the bath, but it could potentially be a cost increase in your drag out, both horizontally and vertically. Temperature is also something that you can increase to help stabilize your process. However, in the bullet above, that can be a cost burden in the fact that it also increases your drag out. Higher concentrations are okay, except they increase your rinsing times and your rinsability. They can also impact the compatibility with your parts and or the equipment that you're using. So the key in having a cleaning agent is for it to be repeatable. Something that's clean on day one may be very different on day 30. And so you need a process that's very stable and in control. Speaking of rinsing, you're only as clean as the final rinse. If we look at two products, one is pH neutral, the other is a more balanced cleaner, the question becomes which one's going to rinse better. And it's pretty easy by looking at these to have a feeling about how they're going to rinse. The one on the left, you can see has some globules in addition to the really thick top layer, where the one on the right, those soils are kind of dispersed through the layers and they're not sticking to the walls of the glass. And so it's a balanced product. And when we talk about balanced cleaning products, they're kind of made up of three big chunks of things. One is the solvent package. The solvent's there to dissolve your non-polar residues, some things, some resins and rosins and stuff that are in flux. The aqueous package is there to help dissolve the polar soils, the salts that are there. And then there's functional additives. We've talked about the benefits of buffers, but there's other things like defoaming agents, wetting agents to help reduce surface tension, corrosion inhibitors to protect sensitive metals or metals in general. But it's the packaging of all of these things that really make a big difference in the bath life and the bath loading potential, as well as making sure that you can use the product at a reduced concentration and a reduced temperature. So we're not having to increase our concentrations and temperatures to maintain the cleaning throughout the bath, the life of the bath. So when we talk about pH, if we're only talking about pH, we're really not looking at a balanced solution. And the key is that we want balance before pH. pH is nice, but balance is better. And if you have a balanced cleaning agent and a balanced cleaning process, you're going to clean, you're going to have all the compatibility you need. The ESG requirements will be met easily. You'll have a stable, long-term process that's very repeatable. And that's really important. So when we look at the myth versus the reality, your pH cleaner is kind of like your Christmas Sasquatch. Sounds good, but it may not deliver. However, your balance cleaner is going to clean. It's going to provide you the compatibility on the machine, the parts, the whole process, easily meet your ESG needs, and that being the environment inside and outside. And it's going to help you control your costs. You're going to be able to maintain low concentrations and low temperatures. So when we ask, do you really need a neutral pH cleaner? It's really about balance, not pH alone. So make sure that you've got a balanced cleaning agent. With that, I will send it back to William for questions.
Awesome. Thank you, Eric. If you would like to discuss this topic further, please contact your local Kaizen representative or send an email to tech@kaizen.com. And we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.